Hello everyone. In this video, I want to cover fields that uses digital image processing or applications of digital image processing. Here I am going to explain the applications of digital image processing by considering the energy used to capture the image. We know how to capture the image. See, to capture the image, there must be a sunlight, or you must focus a light onto the object. Not only the light energy, we have many other energy sources by which you can get the images. Those energy sources are here expressed as electromagnetic energy spectrum. Electromagnetic energy spectrum consists of various rays, and these are divided according to their energy. Yes, here the highest energy is for gamma rays and the lowest energy is for radio waves. The total electromagnetic energy spectrum consists of gamma rays, X-rays, ultraviolet, visible, infrared, microwaves and radio waves. I am going to explain the applications of digital image processing with respect to all these energy sources. The other energy sources are acoustic, ultrasonic and electronic. Now we'll see one by one. First one is gamma ray imaging. The applications of gamma ray imaging is mainly in medical imaging. Here the images are taken by sending gamma rays into the body. There is a separate arrangement to generate gamma rays and to send gamma rays into the body and to collect the gamma rays from the body and to obtain that gamma ray image. So the first one is complete bone scan used to locate sites of bone pathology such as infections or tumors. So this bone scan image is used to identify infections or tumors present in bones. And this is, from this image, you can obtain the tumor parts. Here in the head there is a tumor, white part is the tumor, and in the chest also there is a tumor. So this is the tumor part and this is also tumor part. Yes, you can get the information of these two tumors by using gamma ray imaging. Next is X-ray imaging. The applications of X-ray imaging are medical diagnostics, industries and astronomy. This first image, chest X-ray image. From this chest X-ray image, the information regarding the lungs can be obtained. And the second one is angiogram. Angiogram is the image that shows the blood vessel structures, which is very important for a cardiac patient. This is the head CT, from which we can get the details of the head. And these three comes under the medical diagnostics. Now this is the circuit board image, X-ray image. Images are obtained by sending X-rays onto the objects. This circuit board is used to examine flaws in manufacturing such as missing components or broken traces. So with this X-ray imaging of the circuit board, we are going to get the location where there is missing component or broken traces. And coming to the astronomy, this is the Cygnus loop. Cygnus loop is simply emission from the stars. From the Cygnus loop, the scientists will get information regarding the stars and their emissions. The next is imaging in the ultraviolet band. The applications are lithography, industrial inspection, microscopy, lasers, biological imaging and astronomical observations. Okay, see the example of the applications. You must remember here one point. This is imaging in the ultraviolet band, means the images are obtained by sending ultraviolet rays into the objects. Okay, so this is the normal cone image. This is the structure of the normal cone, and this is the structure of cone infected by smut. Smut is a disease for the cone. As cone is the most popular food, identifying the diseases in the normal cone is very important. Smut is a type of fungus. It causes ill health to the human being. This is again the Cygnus loop by ultraviolet rays. And now, imaging in the visible band. The applications includes light microscopy, astronomy, remote sensing, industry and law enforcement. What is light microscopy? Simply it is about microscopic images. All these images from A to F are the microscopic images. Here light is fall onto the object and the light microscopy gives magnified images of even a small object. So if you see one by one, first one is Taxol anti-cancer agent magnified by 250 times. Second one is cholesterol 40 times magnified. Third one is microprocessor 60 times magnified. And this is nickel oxide thin film 600 times magnified. And this is surface of audio CD 1750 times magnified. And the last one is organic superconductor 450 times magnified. What are you going to get by having these light microscopy images? We're going to get even small details or small deformations or small deficiencies present in these images so that we can take corrective actions. Yes, another application in the imaging in the visible band is in the industry to inspect manufactured goods. See the first one. It is the controller board for a CD-ROM drive. A typical image processing task is to inspect them for missing parts. Okay. So with this image, you can identify the missing parts. See this, the black part, in this black portion, the component is missed. You can obtain this only by image processing. And the second one is imaged pill container. The objective is to find missing, incomplete or deformed pills by having this image. And in the bottle industry, the image processing is used to look for bottles that are not filled up to an acceptable level. Now here are the 5 bottles. This one is not filled up to the mark. Identifying each and every object with a human eye is very difficult. So for that case, image processing is used to identify the incomplete bottles. Yes, these are some other applications of digital image processing in the visible band imaging. The first one is used to identify the air bubbles in plastic product. It can also identify these type of anomalies in wood and cloth also. Yes, another use is inspection for color in the presence of anomalies such as burn flakes in cereal. So image processing is used to identify the anomalies present in cereal, which is very important because it is food. And the other one is used to find the deformations present in the lens, imperfections present in the lens. So by inspecting or by finding all these type of deformation or anomalies, you can take corrective actions. Another application is about the law enforcement. See this is the thumbprint. These images are processed by the computer either to enhance them or to find features that aid in the automated search of database for potential matches. Another one is paper currency. The image processing in this concept is used to automatic counting. In law enforcement, the reading of the serial number for the purpose of tracking and identifying currency bills. Next is automated license plate reading. License plate and other applications of character recognition are used extensively for traffic monitoring and surveillance. Now it is imaging in both visible and infrared bands. Here the imaging is by both visible and infrared rays. Totally the visible and infrared band is divided into 7 bands. These are called thematic bands in NASA's Landsat satellites. The name of the bands are visible blue, visible green, visible red, near infrared, middle infrared, thermal infrared, shortwave infrared, and these are the wavelengths and these are the characteristics and uses. So now these thematic bands are used in remote sensing concept. What is meant by remote sensing? Purpose of monitoring environmental conditions on the planet. See here is an example which shows the images taken in these 7 bands. And these are the uses. Suppose if you take the image in visible blue, you can obtain the details about maximum water penetration in the earth. Landsat satellite images of the Washington DC area. NASA satellite takes pictures from the space and it sends those pictures to the earth, and on the earth those images are analyzed to find all these details. These are the 7 pictures. The next application for both visible and infrared band is weather observation and prediction. The satellite image of Hurricane Katrina taken on August 29, 2005. With this imaging, you can obtain the details of hurricanes. And this is the center of the eye of the hurricane at which it is concentrated. So these are all by image processing. Imagine without image processing, what we can do. This is imaging in infrared band. The satellite image of America. All these light spots are nothing but lights. This image is in the night time. So why this image is taken? This is used to find relative percent of total electrical energy used by various regions. Okay, so image processing is also used to find the percent of total electrical energy used by various regions. Next, imaging in the microwave band. See, the principal application of imaging in the microwave band is radar. Radar will take the images and it will send the images to the earth. The unique feature of imaging radar is its ability to collect data at any time, regardless of any weather or lighting conditions. Even some radars can penetrate through clouds, dry sand, etc. Irrespective of the environment, radar can take the image. Radar can capture the image of even the inaccessible regions of the Earth's surface. So this is spaceborne radar image of mountainous region in southeast Tibet. Radar will take this image, and by getting this image with the image processing techniques, we are going to get much of information regarding those regions. The next one is imaging in the radio band. The applications are medicine and astronomy. Yes, we know the radio band is the last band of the electromagnetic spectrum. The applications are medicine and astronomy. In medicine, radio waves are used in magnetic resonance imaging. We know in magnetic resonance imaging means MRI, which is a very familiar thing to us. This is MRI image of the human knee. And this is the MRI image of the human spine. So by getting these images, physicians will get the information regarding any abnormalities or any damages or any fractures present in knees or spines, so that they can give right treatment. In the application of astronomy, these are the images of the crab pulsar. Crab pulsar means is the center star of the nebula. Emission of light by the center star of the nebula. These are all the images of crab pulsar, gamma ray imaging, X-ray imaging, optical imaging, infrared imaging and radio imaging. Okay. So this completes actually the electromagnetic spectrum part. Addition with the electromagnetic spectrum energy sources, we have other energy sources like acoustic imaging. Acoustic imaging is divided into 2 parts, sound and ultrasound. Sound means hundreds of hertz. The applications includes geological exploration, industry and medicine. In the geological exploration concept, image processing is used to find the mineral and oil exploration. Say this is the cross-sectional image of a seismic model. This arrow points to a hydrocarbon, means oil or gas trap. Means at these spaces, at these lines, yes, there exists hydrocarbon traps, means there exists oil or gas. Another important application of acoustic imaging is ultrasound imaging. The range is millions of Hz. Applications are in medicine, especially in obstetrics, where fetus are imaged to determine the health of their development. See, these are the images of fetuses. This is one angle and this is another angle. These ultrasound imaging is also used to find thyroids and also lesions in muscle layers. See this is the thyroid and this is the lesion. These are all unnecessary parts of the human body which causes even very damaged health, and it leads to the death also. So that these imaging techniques are very, very important. The image processing is very important. And I can say it is used to save the lives of the people. And the last one is electron microscopy. There exist two types of microscopy: light microscopy, electron microscopy. In the light microscopy, light is focused to image a specimen. In electron microscopy, electron beam is focused. The difference is the magnification obtained by the light microscopy is less compared to the electron microscopy. See, for example, the light magnification is on the order of 1000 times, but electron microscopies can achieve magnification of 10,000 times. See, these are the examples of electron microscopy. 250 times magnified image of tungsten filament following thermal failure. See this? In this part, see this pieces, all these pieces, there exists thermal failure. 250 times magnified, you must tungsten filament. Imagine a small tungsten filament, how much small it is filament. But if you magnify it by 250 times using this electron microscopy, yes, you're going to get the details of that failure also, even for that small filament. And this is 2500 times magnified part of an integrated circuit. See, I see how small it is. But with this electron microscopy, yes, you can obtain 2500 times magnified version of the integrated circuit. White fibers or oxides resulting from thermal destruction. So these are all the applications of image processing. Explain every application with images. But how to write an exam? In exam, if they ask, explain the applications of digital image processing. Yes, what you have to do is, you must write all the information, all the text I have given. That is enough. But to understand and to explain it clearly, I take an example images. All these images are from Gonzalez textbook. Okay, please go through the Gonzalez textbook. So with this introduction part of the image processing is completed, in the next class we'll go for fundamental steps in digital image processing. Okay. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.